Hello YouTube family, this is Farmhouse of IT. Let's start the video. Curious about the devices that make your network run smoothly? From routers to switches, these essential tools are the backbone of any network, big or small. Welcome to Whiteboard Doodles, the channel where we simplify tech-related concepts using whiteboard animations. Today, we're diving into the world of network devices, explaining what they do and how they work together to keep your data flowing. Let's get started. Network devices are essential components that enable the smooth functioning of communication systems within a network. These hardware tools, including routers, switches, hubs, modems, and access points, play a crucial role in connecting various devices, such as computers, servers, and other peripherals, allowing them to exchange information seamlessly. Each device performs a specific task, from routing data between networks to managing traffic within a local network, or even providing access to the internet. By ensuring that data is transmitted efficiently and securely, these devices help create the infrastructure necessary for everything from small home networks to complex enterprise systems. Without them, reliable and organized data flow would be impossible, as they form the backbone of modern connectivity. First, let's analyze the key component in any network, the router. Routers are essential network devices that facilitate communication between different networks by directing data packets to their appropriate destinations. They operate at the network layer of the OSI model, making intelligent decisions about where to send data based on IP addresses. By connecting multiple devices within a local area network and linking that LAN to the internet, routers enable seamless data flow between devices such as computers, smartphones, and printers. Additionally, routers often include built-in security features such as firewalls and network address translation to protect internal devices from external threats. With their ability to manage traffic efficiently and prioritize data, routers are fundamental to both home and enterprise networks, ensuring reliable and organized connectivity. If you want to learn more about the OSI model, IP addresses, firewalls, and network protocols like NAT, be sure to check out our separate videos on each of these topics linked in the video description. Next, let's explore switches, another essential component of network infrastructure. Switches are crucial network devices that facilitate communication between multiple devices within a local area network. They operate at the data link layer of the OSI model and are designed to receive, process, and forward data to the appropriate destination device, ensuring efficient data transfer. Unlike routers, which connect different networks and direct traffic based on IP addresses, switches function primarily within a single network, using MAC addresses to determine where to send the data. This means that when a switch receives a data packet, it examines the packet's destination MAC address and forwards it only to the designated device, minimizing network congestion. Other devices, such as computers, printers, and servers, connect to the switch via Ethernet cables, allowing for seamless communication and resource sharing within the network. For more information on MAC addresses, we recommend watching our video on the topic, which will be linked in the video description. Next, let's take a look at the hub, one of the most fundamental devices in early network setups. A hub connects several computers or devices within a local area network, but operates with far less sophistication than more modern equipment like switches or routers. Instead of directing data to specific devices, a hub simply broadcasts any data it receives to all connected devices, regardless of its intended destination. This results in network inefficiencies and potential collisions, as every device processes the data, whether it's meant for them or not. Though widely used in the past, hubs have largely been replaced by switches due to their superior ability to manage network traffic. Now let's look at another essential device in your network setup, the modem. Short for modulator-demodulator, a modem connects your local network to the internet by converting digital data from your devices into analog signals that can be transmitted over telephone lines, cable, or fiber optics, and vice versa. Unlike a router, which directs traffic within a local network and between different networks, a modem's primary function is to provide access to the internet by communicating with your Internet Service Provider, or ISP. In many modern setups, A modem-router combination device is used, combining the modem's ability to connect to the internet with the router's role of managing and directing data between devices within your local network. While standalone modems and routers offer more flexibility for configuration and upgrades, the combination device is a convenient, all-in-one solution for many households. Next, let's take a look at access points, or APs. An access point is a device that plays a crucial role in expanding your wireless network. While many routers come with built-in Wi-Fi capabilities, access points are specifically designed to extend wireless coverage in areas where the router's signal may be weak or inconsistent. They connect to the router using Ethernet cables, allowing them to broadcast a strong Wi-Fi signal over a larger area. This is particularly beneficial in larger homes, offices, or buildings where a single router may struggle to provide adequate coverage. By strategically placing access points throughout the space, you can ensure that more devices can connect wirelessly without overloading the main router. This setup not only enhances connectivity, but also improves overall network performance, as it reduces the likelihood of dropped connections or slow internet speeds. Let's now discuss an essential component of network security, the firewall. Firewalls act as a security barrier between your internal network and the internet, monitoring and controlling incoming and outgoing traffic based on established security rules. A hardware firewall is typically installed at the network's entry point, ensuring that any data trying to enter or leave the network is thoroughly inspected. By filtering out malicious traffic and allowing only authorized data to pass through, firewalls help prevent unauthorized access, malware, and other cyber threats from infiltrating your network. For more insights into how firewalls work and their crucial role in network security, be sure to check out our separate video on firewalls linked in the description below. Next, let's examine an essential component in every network device, the Network Interface Card, or NIC. An NIC is responsible for enabling a computer, printer, or other device to connect to a network by acting as the bridge between the device and the network itself. Found either integrated into a device's motherboard or as an external card, an NIC facilitates communication by creating a pathway for data to flow in and out of the device. Available in both wired and wireless versions, NICs can connect devices to Ethernet networks through a cable or wirelessly through Wi-Fi, making them versatile for various network setups. In addition to establishing connectivity, an NIC translates data into a format suitable for transmission over the network, ensuring that devices can seamlessly share files, access resources, and communicate with one another across the network. Now let's explore the function of repeaters. A repeater is a device that regenerates and amplifies signals to extend the reach of a network, effectively bridging the gap between two distant points. When data travels over a network, the signal can weaken due to distance or obstacles. A repeater boosts this signal, allowing it to travel further without degradation. Unlike access points, which create new wireless networks or enhance existing ones, repeaters simply receive signals and retransmit them, ensuring that data can travel across larger areas. This makes repeaters particularly useful in environments where physical barriers might hinder connectivity, helping maintain a stable and robust network connection throughout the space. Let's move on to another essential networking device, the bridge. A network bridge connects two or more network segments, allowing them to function as a single unified network. By linking these segments, a bridge enables devices on each segment to communicate with one another, expanding the network while keeping data flow organized. Unlike routers which operate at the network layer, bridges work at the data link layer, using MAC addresses to decide where to forward data. This selective forwarding reduces unnecessary traffic, improving network performance. Although bridges are less common today due to advancements in switches, they still play a valuable role in managing data flow in smaller or segmented networks. The next network device on our list is the gateway. A gateway connects different networks, often with varying protocols, and enables them to communicate seamlessly. It acts as a translator between networks that operate on different systems or standards, converting data into a compatible format so information can pass between them. Gateways are especially important in larger networks, such as those found in organizations, where they connect local networks to external networks like the internet. Unlike a router, which primarily directs data traffic within or between similar networks, a gateway can link completely different network types. This device helps ensure compatibility and communication across diverse systems, supporting smooth data transfer and resource sharing across a wide range of network environments. For more on network protocols, check out our video linked in the description. Lastly, let's take a look at the load balancer. A load balancer is a critical network device used to manage traffic across multiple servers or resources to ensure smooth and reliable network performance. By distributing incoming data requests evenly, a load balancer helps prevent any single server from becoming overloaded, which can lead to slower response times or even system crashes. Load balancers are commonly used in environments with high traffic or multiple resources, such as large websites or cloud-based services, to maximize efficiency and uptime. They also monitor the health of servers in real time, automatically redirecting traffic if a server goes down, ensuring continuity of service. This makes load balancers invaluable for maintaining optimal network performance and user experience, particularly in larger networks where consistent availability is essential. In conclusion, understanding the different network devices and their roles provides a foundation for creating efficient, reliable networks. Each device, whether a router, switch, firewall, or gateway, serves a specific purpose in managing data flow, security, and connectivity across local and external networks. Knowing how and when to use these devices can help ensure smoother communication, enhanced security, and better performance across your network setup, giving you the tools to navigate the basics of networking with confidence. This marks the end of our exploration of common network devices. If you enjoyed it, consider subscribing to our channel and liking the video. Feel free to also check out our other videos on related topics. Thank you for watching.